So we have exponentials on both sides, but they're the only thing going on. Then we're going to use that second method to handle this, that power rule. If we take our logs of both sides, if we take a logarithm, doesn't matter which one of both sides, we'll be able to take down these exponents out in front. So that's exactly what we're going to do. I'm going to go ahead and use natural log just because it has the least amount of letters for me to write. No other reason. So we're going to take the natural log of both sides. Bloop, bloop. All right, this is going to allow us to write that x plus 1 with some parentheses out in front of the ln of 2. And here's where we have to know and be cognizant that the ln of 2 is just a freaking number, right? It's some weird-ass decimal number, but the ln of 2, I can type that into my calculator. There it is. It's 0.693. So it is just a number. And then we'll do the same thing with the other side of this. This is all equal to, again, we get to bring down the exponent because of the power rule. So 2x minus 1, making sure I have parentheses, and then I have the ln of 5, which again is just a number. So here's where we need to recognize, okay, sure. I can go ahead and distribute these numbers, as gross and ugly as they are, to both terms in that binomial expression that used to be my exponent. So we have the ln of 2x plus the ln of 2 on the left side. We have 2 ln of 5x minus the ln of 5 on the right side. I could even make that the ln of 25 if I wanted to, using my power rule to make that a little simpler, but it doesn't matter. I'm good. And now we're going to do our normal steps to solve for a variable, right? If we have a variable, we just have two x's. We typically want to move them to one side, right? Not move is a bad mathematical term, but we'd like to have our variables on the same side of the equation and then our constant terms on the same side of the equation. So we can choose which way we want things to, for lack of a better word, move. Because I don't like negatives, I'm going to go ahead, I'm going to add the ln of 5 to both sides. So I am making a decision that numbers are ending up on the left, which I know is contrary to how we usually like to write things, but it's just my hatred for negative signs supersedes the need to have variable equals number. I'd rather have number equals variable if there are negatives involved. And then that means if all the green stuff is supposed to end up over here, if that was the goal, then all the yellow stuff, all of my stuff with variables in it's got to end up on the right-hand side. So I will go ahead and I will subtract off this ln 2x, my minus side, from both sides. Oh, this is confusing. Ln of 2 times, I need to like put that in parentheses, huh? Same thing with this guy. Because otherwise it looks like the 5x, or the x is inside of the argument of the natural log. Whew, confusing. I don't even know if we're supposed to, coefficients are typically in front of variables, but yeah, lots going on there. So now we're at our final two sides, right? So this side is the ln of 2 plus the ln of 5. That's why I did it that direction, otherwise I'd have two negatives, and I hate that. And then I have 2 ln of 5 as my coefficient on an x, minus the ln of 2 as my coefficient on another x. And we got a factor, right? We can see there are x's in both of these, and we can factor out 2 ln of 5 minus the ln of 2 with an x on the outside. And so then we got, now we have two things multiplied together on the right. We can just divide out this gnarly logarithmic expression. 2 ln of 5 minus the ln of 2. So here is our exact answer for what x is. X is equal to the ln of 2 plus the ln of 5. Technically, didn't have to be ln's, right? It could have been natural logs, whatever. Divided by the quantity 2 ln of 5 minus the ln of 2. So this is going to be some gross-ass approximation. Let's go ahead and type it into my calculator. I'll use parentheses. The ln of 2 plus the ln of 5 divided by, need more parentheses, 2 ln of 5 minus the ln of 2. Close. Oh, I did not close a parenthesis. You guys should have been yelling at the YouTube screen. Come on. There we go. So 0.91165. I'll just do 0.912. So the little moment of consternation that was happening there is I hate rounding when the final digit is like a 5 or a 4 because it just means it was like rounding. It was so close to something else. I mean, not that it would be worse to go 0.117 versus 0.112, but I just feel slightly better about it. So it is positive. Whew. Now I'm going to check my work. We had this gross original 2 to the 0.912. I'll use that 3 decimal approximation plus 1. That's not a 1. Should be the same as 5 to the 2 times 0.912 minus 1. Of course, they're not going to be perfect because we did approximate, but they're pretty dang close. They're good to the second decimal place. I feel good about this. So there we go. There's our exact and our approximate answers to this problem. Beautiful. All right, so we will tackle one more. We already did these ones in class, but the ones that are reducible to a quadratic, that's the last thing I want us to see. So those are situations where, oops, I keep doing this, I keep previewing what's coming. Those are situations where we end up with more than one exponential term. So something like this, 2e to the 2x minus e to the x minus 132 is equal to 0. We have more than one exponential term, right? But in this case, we can't just, there's an other term as well. There's this 132, this constant. So we can't just have two sides and take the natural log to both sides. In fact, if you try to take the natural log when you have a bunch of stuff going on, you really, I mean, first off, we couldn't because of the 0. The natural log of 0 doesn't exist. But even if we moved the 132 over, when you have multiple terms, we don't want to be taking a log because we don't have any rule that lets us do anything with like this. This does not equal the natural log of A plus the natural log of B. So we cannot do anything cool when there are multiple terms on a side. So this is one where we need to do that U sub and change this thing into a quadratic expression to be able to solve out what we're doing. So if you want a refresher on that, stick around for the next video. Otherwise, you are good. You've seen all of it in terms of exponentials, and you can move on to the logarithmic equations if you need to.